Hello friends, myself Dattatre Jadhav. I am from HM College Karad. Today we are going to see new theorem on substitution. So integration by substitution. Theorem is what? Theorem is if x is equal to phi of t is differentiable function of t, then show that integration of f of x dx is equal to integration of f of x dx is equal to integration of f of, here x is differentiable, x is equal to phi of t, so f of phi of t into phi dash of t dt. Okay. So, starting with proof of the above theorem is, remember the proof of this theorem by 4 steps. First one is given, second one is let, third one is consider, and fourth one is by definition of integration. Okay, if we remember these 4 steps, then proof of the theorem is easy. Okay, so starting with first step in proof, given is there. Given, what is given? The part after it is given. Given what? X is equal to phi of t is differentiable function of t. Okay, so given x is equal to phi of t is differentiable function of t, means what? We differentiate with respect to t. Differentiating with respect to t, we get dx by dt is equal to derivative of phi of t is phi dash of t, which is our equation number first. Okay, now the second step is let. So let what? Let consider that integration as g of x. Let integration of f of x dx is equal to g of x. त्या f of x काहीतरी इंटिग्रेशन आहे ते मी मानलेले आहे g of x. Therefore, by definition of integration, if the integration of f of x is g of x, then derivative of g of x is f of x. So d dx g of x is equal to f of x. Here is equation number second. Now third step is consider what? Here is the term d dx of g of x, but x is function of t, so differentiate with respect to t. Now considering derivative with respect to t of g of x, that is d dt of g of x, which is equal to, d dt of g of x is equal to, this can be written as d dx of g of x into dx by dt, means we adjusting the term dx, and the reason for that by chain rule. Yes, you remember dy by dx is equal to dy by du divided by dy by dx is equal to dy by du into du by dx. So which is equal to d dx of g of x. D dx of g of x from equation second, the value of d dx of g of x is f of x into dx by dt as it is. Now from equation first, x is equal to phi of t and dx by dt is equal to phi dash of t. It's our equation number first. From equation first, this can be written as f of, instead of x I can write phi of t, f of phi of t into dx by dt is nothing but phi dash of t. Okay, so we get d dt of g of x is equal to f of phi of t into phi dash of t. Okay, we know the definition of integration. E d dx of f of x is equal to g of x, then we say that integration of g of x dx is equal to f of x. Okay, ddx of f of x is g of x, then we say that this implies integration of g of x dx is equal to f of x. Okay, similarly look at here, consider that term as f of x, so ddx of f of x is equal to g of x, so integration of this term is okay, or simply you must remember by taking integration on both the sides. Okay, taking integration on both the sides, with respect to x, or directly you use the definition of integration. So taking integration on both the sides with respect to t, because function is in t. So integration of d dt of g of x is equal to integration of d dt of g of x dt is equal to integration of f of phi of t into phi dash of t dt. Okay, here integration and derivative are inverse processes of each other, so integration and derivative cancels, dt also cancel. What's remaining here? G of x is equal to integration of f of phi of t into phi dash of t dt, which is equal to, but g of x is what? We assume g of x as integration of f of x is, so integration of f of x dx is equal to integration of f of phi of t into phi dash of t dt. Hence the proof. Okay, proof of this theorem is over. Okay, just remember these four steps given. Let consider by definition of integration. Okay, so given is x is equal to phi of t, differentiate with respect to t, we get dx by dt is equal to phi dash of t. Let integration of f of x dx is equal to g of x, so ddx of g of x is equal to f of x, equation number second. Now differentiate g of x with respect to t. Consider d dt of g of x is equal to ddx of g of x into dx by dt by chain rule. But ddx of g of x is f of x into dx by dt. Replace x from equation 1. X is equal to phi of t. Replace x by phi of t. F of phi of t into phi dash of t. Okay. D dt of g of x is equal to f of phi of t into phi dash of t. So g of x is nothing but integration of RHS. So g of x is equal to integration of f of phi of t into phi dash of t dt. What is g of x? It's integration of f of x dx. So integration of f of x dx is equal to f of phi of t into phi dash of t dt. हा थेरम आपण काय कसा यूज करणार आहे बघा. हा थेरम आपण रिव्हर्स यूज करणार आहे, फ्रॉम राईट टू लेफ्ट. ओके, बघा इकडे राईट लाईन इंटिग्रेशन मध्ये भरपूर टर्म्स आहेत आणि लेफ्ट लाईन इंटिग्रेशन मध्ये एकच टर्म आहे. ओके, म्हणजे एखाद्या वेळेस आपल्याला एक्झाम्पल सॉल्व्ह करण्यासाठी काय करावं लागेल, तर मोठे एक्झाम्पल कन्वर्ट करायचं असेल लहान स्टँडर्ड फॉर्मला, तर आपण हा सबस्टिट्यूशन थेरम वापरणार आहे. Remember, we substitute for those terms whose derivative is present in the integration. ज्याची डेरिव्हेटिव्ह इंटिग्रेशन मध्ये असेल अशा फंक्शन बद्दलच सबस्टिट्यूशन करणार आहे. ओके, सो नेक्स्ट corollary on this theorem. First corollary is if integration of f of x dx is equal to phi of x. First corollary, if integration of f of x dx is equal to phi of x plus c. जर f of x चे इंटिग्रेशन काहीतरी येत असेल phi of x plus c, then integration of f of linear equation, that is linear equation represented by ax plus b dx is equal to phi of ax plus b divided by a plus constant of integration c. Okay, now we prove this theorem corollary by above theorem. Okay, let I is equal if before the starting proof of this corollary write given. Okay, given integration of f of x dx is equal to phi of x plus c. Okay, this term is given. Let I is equal to solve this integration, I is equal to integration of f of ax plus b dx. Okay, here is the linear equation ax plus b. So put for that term ax plus b is equal to convert the integration to standard form. So substitute put for ax plus b is equal to t. On differentiating, yes, when we differentiate, LHS is in x, RHS in t. Differentiating LHS with respect to x, so we get a into, since it is differentiated with respect to x, so dx is equal to derivative of t with respect to t is 1, since it is differentiated with respect to t, so dt. Okay, multiplied 1 by dt. Or it comes from derivative with respect to x, it's a is equal to derivative of t with respect to x dt by dx. Take dx on LHS. A into dx is equal to dt. Okay, so but there is term in integration dx. I can find the value of only dx. Dx is nothing but dt divided by a. So integration becomes I is equal to, we substitute for ax plus b as t. So f is as it is ax plus b, write ax plus b as instead of ax plus b it's t. F of t into value of dx is dt divided by a. We know that here a is constant. Take outside the integration sign. So 1 upon a into integration of it's f of t dt. Okay. Tell me integration of f is what? Given integration of f is phi. So integration of f of x dx is phi of x plus c. So integration of f of t is what? Integration of f of t is, yes, 1 upon a as it is into integration of f is phi. So integration of f of t is phi of t plus constant of integration c. Okay. Now corollary is in x. Because of substitution we are in variable t. So resubstitute value of t. T is what? X plus b. So I is equal to 1 upon a into, replace t by ax plus b, phi of ax plus b plus constant of integration c. So phi of ax plus b divided by a plus constant of integration c. What is that? I is integration of f of ax plus b dx. Integration of f of ax plus b dx is equal to phi of ax plus b divided by a plus. Okay, for example, here is that example, evaluate integration of e raised to 2x plus 5 dx, which is equal to, okay, look at here. Here is a linear equation. 2x plus 5 is a linear equation. So consider that 2x plus 5 as x. It looks nice. E raised to x dx. We know the integration of e raised to x. Integration of e raised to x is e raised to x. So integration of e raised to 2x plus 5 is e raised to 2x plus 5 divided by, yes, here is that coefficient of x. Here coefficient of x is 2 plus constant of integration c. Or take another example. Evaluate integration sine of 3x minus 2 dx, which is equal to, okay, sine of 3x minus 2 dx. Here, yes, there is a linear equation 3x minus 2. okay, which is different from x. So we use this corollary. Okay, corollary says that if integration of f of x dx is equal to 5x plus c, then integration of f of x plus b dx is 5x plus b divided by a plus constant of integration c. Okay, consider 3x minus 2 as x. So we get sin x dx. Integration of sin is what? Integration of sin is minus cos. Okay, derivative of sin x is cos x. Derivative of cos x is minus sin x. So integration of sin x is minus cos x. Okay, so minus cos px minus 2. What is x? So 3x minus 2 divided by coefficient of x is 3 plus constant of integration c. Okay, it's our corollary number first. Okay, next corollary number second. If or prove that, second corollary is prove that integration of f of x f dash of x divided by f of x dx is equal to log of mod of f of x plus c. Okay, it's our corollary number second. Prove that integration of f dash of x divided by f of x dx is equal to log of mod of f of x plus c. Okay, here f of x is a function and f dash of x is the derivative of that function. Okay, if in denominator function there is a function and in numerator there is a derivative of that function which is in denominator, then answer of such type of integration is directly written as log of mod of f of x plus c. Okay, so proof of the above corollary is let I is equal to, consider that integration by I, let I is equal to f dash of x divided by f of x dx. Okay, आपण आताच थेरम बघितलेला आहे. थेरम मध्ये काय सांगितलेलं होतं? सबस्टिट्यूशन थेरम मध्ये आपण असं पाहिलेलं आहे, सबस्टिट्यूशन कोणाबद्दल करायची ज्याची डेरिव्हेटिव्ह त्या फंक्शन मध्ये इंटिग्रेशन मध्ये आहे अशा फंक्शन बद्दल. सो whose derivative is present in given integration? Derivative of f of x is f dash of x. So put f of x is equal to t. Substitute for that term whose derivative is inside the example. Okay, since derivative of f of x is f dash of x, so I can substitute for f of x is equal to t. Okay, here term in x, here x is variable, we substitute another variable for f of x, that is t. Okay, on differentiating, tell me the derivative of f of x. Derivative of f of x is f dash of x is equal to, yes, derivative of t with respect to x, that is dt by dx. So simply we can write f dash of x into dx is equal to dt dx on LHS. Okay, but you don't write this f dash of x is equal to dt by dx. Okay, in exams. Okay, so directly write put f of x is equal to t. Derivative of f of x is f dash of x. When it is f dash of x, when it is differentiated with respect to x, so multiply it by dx. And derivative of t with respect to t is 1, so multiply it by dt, since it is differentiated with respect to t. Okay, here is that term f dash of x dx. Okay, instead of f dash of x dx, I can write this as dt divided by f of x is what? It's t. Now confirm your example is changes to new variable t. Okay, all the terms in the examples are in t. Okay, so which is equal to, I is equal to integration of 1 upon t dt. Okay, dt divided by t is nothing but 1 upon t dt. Now consider t as x, integration of 1 upon x dx. What is the integration of 1 upon x dx? log of mod x. So integration of 1 upon dt is what? So I is equal to integration of 1 upon t dt, and integration of 1 upon t is what? Log of mod t plus constant of integration c. But answer is in t. Why? Because of substitution. So resubstitute for t. T is what? F of x. So log of mod of f of x plus constant of integration c. What is that? I is nothing but integration of f dash of x divided by f of x dx. Okay? It's hence the proof. Okay? For example, evaluate integration. Sec square x divided by tan x dx. Look at here. Here derivative of tan x is what? Sec square x. Okay? Here derivative of tan x is what? Sec square x. Derivative of denominator is in numerator. So directly we can write answer of such type of integration as log of mod of denominator. So log of mod of tan x plus constant of integration c. Okay? जर डिनॉमिनेटर ची डेरिव्हेटिव्ह न्यूमरेटर मध्ये असेल तर ही corollary वापरणार आहे. इंटिग्रेशन च्या आतमध्ये डिनॉमिनेटर ची डेरिव्हेटिव्ह न्यूमरेटर मध्ये असेल तर त्याचा आन्सर डायरेक्टली लिहितो आपण log of mod of f of x plus c. Okay. Next, third corollary is prove that integration of f dash of x divided by root of f of x. Okay? Integration of f dash of x divided by root of f of x dx is equal to 2 root f of x plus constant of integration c. Okay? When we use this corollary when inside the integration in denominator there is a function which is in root and whose derivative is present in numerator. Such a type of integrations answer is 2 into denominator. Okay? So starting with proof, let I is equal to integration of f dash of x divided by root of f of x. Okay? Now tell me whose derivative is there? Yes, derivative of f of x is f dash of x. So substitute for those functions whose derivative is inside the integration set. Okay, here derivative of f of x is f dash of x. So put f of x is equal to new variable. It's the on differentiating. Okay, on differentiating derivative of f of x is what? F dash of x. Okay, when it is f dash of x, when it is differentiated with respect to x, so multiplied by dx is equal to derivative of t is what? 1. When it is t, when it is differentiated with respect to t, so 1 into dt, that is 1 into dt is dt. So I can write directly f dash of x is equal to dt. So integration becomes I is equal to, here is that term f dash of x, instead of f dash of x I can write dt, and instead of f of x I can write t, dt divided by root t. Okay, now this is I is equal to, yes, it looks like 1 upon root t into dt. Okay, 1 upon root t into dt. Yes, we know the integration of 1 upon root x. Integration of 1 upon root x is 2 root x. So integration of 1 upon root t is 2 root t plus c, which is equal to 2 root, replace t by f of x, t by f of x 2 root f of x plus constant of integrations. What is that? Is f dash of x divided by root of f of x dx. So proof of this corollary is over, hence be proved. Okay, we use this corollary only when your denominator is in root and the function inside the root derivative in numerator. Okay, for example, integration of 2x plus 1 divided by root of x square plus x dx. Look at here. First identify type of the integration, and mainly type of the integrations are trigonometric and algebraic. I have explained. So it is example of algebraic. First check substitution is possible or not. Substitution, we substitute for which function whose derivative is there. Tell me the derivative of x square plus x. Derivative of x square is 2x plus derivative of x is 1, means the term in root. Okay, त्याची derivative numerator मध्ये 2x plus 1. So I can write answer of this integration is 2 into denominator. Denominator is what? Root of x square plus x plus constant of integration c. Okay? Okay. Or another example is sin x divided by or cos x divided by root of sin x dx. Okay? Look at here, denominator is in root. Inside the root there is sin x and derivative of sin x is in numerator cos x. So answer is directly what? 2 into denominator. Denominator contains root of sin x plus constant of integration c. Here is the proof of the corollary number 3. And last one, corollary number 4. Prove that integration of f of x bracket raised to n into f dash of x dx is equal to f of x raised to n plus 1 divided by n plus 1 plus constant of integration c, where n is not equal to minus 1. When n is equal to minus 1, so minus 1 plus 1 get cancelled, denominator is 0. So it is not defined. Okay? So proof of the above corollary is, first consider or let I is equal to integration of f of x bracket is to n into f dash of x dx. Since the corollary is on substitution, so we use the substitution here. Put for which term? Put for those terms whose derivative is inside the integration. And we know that derivative of f of x is f dash of x. So put for f of x. Put f of x is equal to t on differentiating. Yes, derivative of f of x is f dash of x. Okay, when it is f dash of x, it is differentiated with respect to x. Then so multiply by dx. Okay, derivative of t is 1 with respect to t. Okay, so 1 into dt. Right. So integration becomes I is equal to integration of here f of x is equal to t. And here is that term f dash of x dx dt. So f of x is equal to t. It becomes t raised to n into dt, which is equal to. We know the integration of x raised to n. Integration of x raised to n is what? X raised to n plus 1 upon n plus 1. So integration of t raised to n is what? T raised to n plus 1 divided by n plus 1 plus constant of integration c. But what is t? What is t? T is f of x. So f of x raised to n plus 1 divided by n plus 1 plus constant of integration c, where n is not equal to n. And LHS is I. What is I? Integration of f of x bracket raised to n into f dash of x dx is equal to f of x raised to n plus 1 divided by n plus 1 plus constant of integration c. Okay. For example, here is the example. Integration of sin cube x into cos x dx is equal to, look at here, sin cube x can be written as sin x bracket into cos x dx, and corollary says that function's power into its derivative. Okay, the answer of such type of integration is add power by 1 and divide by the same power of that function. Okay, here is that function sin x, derivative of sin x is cos x. Okay, so add power by 1, sin x raised to 4 divided by 4 plus constant of integration c. This is simply write as sin 4x divided by 4 plus constant of integration c. Okay, here is the fourth corollary. I hope you understand all these corollaries. Okay, thank you.